this way, Anil. You've got a seat if you like. Good afternoon, everyone. Welcome or welcome back to PyCampus. Many of you, many known faces and a couple of new faces. I'm really happy to see all of you today. We're doing pitch day for session 13 of School of AI. I'm going to say a few words about where you are, for those of you who are new here. And then we're going to have presentations from the fellows on the PySchool of AI program. And then I'm going to be back with a couple of news regarding PySchool. So this is PyCampus. It's both an investment fund, a seed investment fund. So we invest in startups when they're very young. We invest between 50 and 500,000 euros. And in exchange, we take a few of their shares. And we take them through their life until there is an exit or until they join the dead pool, which is what happens to many entrepreneurs, which then, luckily and often enough, restart new startup life and then end up being serial entrepreneurs. And these are especially valuable to PyCampus. And so a couple of these also in the portfolio. Okay, many of the startups, as you can imagine, are in the applied AI field, and this has been the case ever since PyCampus started back in 2016 and even before. We've got more than 60 investments today, and the PySchool of AI program that was born out of PySchool, one of the companies in the PyCampus portfolio, is our response to what was very true back in 2017 when we started and is still true today, our response to the lack of talent and the lack of experience with companies in AI. So in companies, the way this materializes especially is we see, and it's different in a different way, it's true in a different way today, because we see that many of our of the companies who come and speak to us see that, well, others are doing projects in AI, or they hear of, or they're convinced that something can be done, but they don't have very much experience. They don't know exactly where to start, and often enough they don't have people who can implement the projects they'd like to do. And where PySchool intervenes is exactly there, is in getting them started and prototyping their first few projects to help them get going and sort of take them from essentially from zero to hero in a way, so that they can then develop a portfolio of AI projects on their own. So the way that the program works, i.e. the mechanics of how we solve this business pain essentially, is we bring together those two ingredients. On the one hand, we look at the business pain that the companies come with when they speak to us. We analyze the business pain and we formulate at the onset of the program, before we actually start, we formulate the business pain in a way that maps to an AI problem. We also look at the same time at the state of the art, the scientific state of the art in machine learning, in computer vision, in natural language processing, and we try and figure out what in the state of the art might answer the business pain that we're seeing. This is especially important because, as I was commenting to Saverio just earlier on, Saverio is one of the sponsors of this session, we're seeing that ever since we started in session 1, 2017, really, from a now historical perspective, things do change and do change very drastically. So over the 6 years we've been doing this, the solutions that we've adopted, always solutions at the state of the art in the moment we implement them, well, they look obsolete 6 months later, right? And this is really interesting to monitor, and it also, underlines obviously the incredible pace at which scientific progress in our field happens, and how important it is to essentially keep abreast of this change when we choose the technology that we'll use to implement the solution. We have adopted this time-boxed format of 8 weeks ever since the beginning. We produce a working prototype after this time box, and the IP of that, the IP returns to our sponsor. The idea of the time box is that we want to be sure when we start and sure when we stop. We don't want to do sort of consultancy, nothing against consultants, but consultancy projects where there is a hidden incentive essentially to run the project for longer because you get paid for longer. Okay, so this is what we'd like to avoid. This is the reason why we adopt this time-boxed format. And obviously this is inspired, I would say, or motivated by what we see happen to startups in that they burn cash. So they're motivated to do things, you know, with a definite event horizon. And so we've adopted this for that reason here in the PySchool format. We bring together these 3 parties in PySchool. So sponsor is the company that brings usually the business pain, data, so their own data often enough, the work that they've done with the data, the acquisition process for that data, which is usually very tightly connected to their application. So we'll see examples in the presentations later on of how, what this means in practice. And the sponsor is also the party here that pays. So the entire program is free to fellows. So all of these people who you will hear from and who participate in the program don't pay for the experience that it represents for them, because this is supported by our sponsors. Fellows are people from all over the world. We have a pretty global reach, I think. So we get applications, very many. We have a pretty high selectivity, I would say. And we take people through what looks a lot like a technical recruitment process for machine learning engineers, select them, and then we put in their hands, we assign them to these AI problems and let them work with the help of coaching from PySchool staff. And you'll hear a few words from PySchool coaches as well. And then we have mentors who are people from the, I would say, PyCampus network more widely, who are specialists, probably vertical specialists, typically of some technology in AI, or some maybe like business application of AI, something that is narrowly specific and that helps the challenge that we're trying to solve, one of the challenges we're trying to solve. And we've got the stats, so we're now a grown company. We've done 96 challenges, and we've seen 198 alumni, so quite a sizable pool of talent there. These are a couple of the people that the companies that sponsor challenges with us. And without further ado, I'd like to get started with the pitches. You'll hear from the people who worked on these challenges, and they'll be around later on for you to have a chat with them or discuss with them what they did or ask them questions. So without any further delay, over to you, Cristiano, for the first pitch.
Thank you, Seb. Thank you to everybody. So yeah, I will start. I'm Cristiano. I'm the lead AI coach here at PySchool. Basically, I'm presenting this challenge, being that the fellow cannot be here. So I'm the coach, but I'm happy to present this challenge. The name is Booking Optimization through AI. Here, this is very important. Yeah. So, the sponsor of this challenge is La Filanda Agriturismo, which is a farm stay and bed and breakfast located on Lake of Garda. It's also my place. I was born close by to Lake of Garda. And it's a family business. Basically, we have here Marco and Roberto. It's a family business, but run by, I think, you and maybe your family, yeah? Maybe your sister also, okay. No, okay. So if you are interested in joining Garda Lake, you can, you can meet them later. I want to emphasize that, you see, AI is not only stuff for big companies or big tech companies, but also for, you see, a company that is basically in tourism. So you see, it's something for, let's say, everybody. So I would like to present. Let's start. So this agriturismo, it's already a bit tech one, because they already have a software that helps them to, you see, interact with their customers. And today, think about a customer ask for to book a holiday or some relaxed time on Lake of Garda. The request goes through a booking software that generates many possibilities according to the selected dates and the room available, okay? These possibilities, however, are so many that today Marco and Roberto needs to select some of them, okay? Among many possibilities, they select the best 3 options, okay? For the customer. And then the customer can, you see, select not among, I don't know, 30, 50 possibilities, but just 3 options. However, this pipeline has some, let's say, pains. For instance, sometimes there are delays in response time, because Marco and Roberto needs to screen all the possibilities and select the best one. It's also resource intensive. It's also prone to errors, okay? So in order to speed up this process, we help them building an AI booking agent, okay, that receive as an input all the possibilities, all the options generated by the already existing software, and screens them and output the best 3 options for their clients, for the customer. Okay, and this speed up a lot the pipeline. I think from a matter of 1 or 2 days in a matter of maybe milliseconds or seconds. So this was our solution. And you see, there is a secret sauce behind it, not only AI, but somehow the sponsors, so Marco and Roberto, they were clever enough, they were far-sighted, visionary in collecting precisely data and about, you see, from the past. And this is very important. So not only AI, but obviously also you see the mind setting of preparing your company, your startup for the future, let's say. So thanks to this data, our AI booking agent learned the quote to customer fit percentage by training on the behavior of the human expert. Basically, they build up a data set, we call it in machine learning supervised one, where there are all the options with label, which is the fit according to how this option is good or not for the customer. So we fine-tune and train this model on this data set, and these were the results. I would like also to highlight you how at Pi School we used to work. Sebastian mentioned already, but here is an example. So you see, week 1, we start in general with a very simple baseline model. Often this model is not really working. Okay, so you can check the metrics are very low, but doesn't matter. From week 2 and 3 and so on, we are improving our baseline model step by step. Also, thanks to feedback from the sponsor. And so you see from week 2, 3, we went to some model selection, choose the best model, week 4 and 5, do some other improvement, so on and so forth. And we end up week 8, so this week, with, you see the model improved. Then, I would also want to highlight that we were following, when I'm talking about improving, optimizing a model, we are optimizing it according to some metric, okay? Some final goal. Our final goal was this metric, which is called recall. You can think of recall, when you have 100% recall, means that you never miss a good option. This was very important for them, and in general, for business like that. Instead, for instance, accuracy is another metric, which is about getting all the options right, good and bad ones. But instead, we were interested in good options, good quotes, and so recall, it's the case. So you see, we improved from 0.5 to almost 0.9. Through this process. So what's the outcome? The outcome is the pipeline has speed up a lot, reduced delays in response, increasing user satisfaction, and in addition, a better and smooth experience for the customer. So turns into more bookings. So everybody is happier and can enjoy Garda Lake. Thank you. Thank you. Now, I would like to give the floor to Rui. It's gonna presenting the next challenge, which is data insight for crowdfunding. Yeah.
Thank you very much, Cristiano. Good afternoon. I'm Rui. Here is our team member, Oma and Ivan. We are working together for 8 weeks on a project of an online crowdfunding platform, MamaCrowd, which is one of the leading platforms in Italy. We would like to find some business insights of the platform. So we are looking to see something on a crowdfunding platform. So what is crowdfunding? In this stage, the investment is on ongoing transform. So what is this transform? It is called crowdfunding. So the crowdfunding enables everyone to invest some company, which is usually like a small to medium enterprise or a startup company. So in return, those investors can get some share of the company and become the shareholders. So in this transforming process, MamaCrowd is a leading figure in Italian's platform. So you can see some stunning figures here. MamaCrowd has more than 200 projects. It has more than 180 kilo investors. It also has more than 220 million euro investments in this platform. So MamaCrowd is a platform which is to make the dreamers to believers. So the heartbeat of the MamaCrowd is called campaign. What is a campaign? It is a stage where the company bring their project to the world and waiting for the investors to realize their aspirations. So for a campaign, there's usually a minimum goal of money they would like to invest. It is like called the minimum goal. If the campaign ends with, the campaign ends with the successful minimum goal, that means that this campaign is successful. So the investors, they become the shareholders, and MamaCrowd can also get a percentage of the total amount of the fee into this platform. So MamaCrowd is a platform to combining the investors, the companies, and making the dream become true for everyone. So with abundance of data behind the MamaCrowd platform lies a very rich and diverse database of users, companies, and campaigns. However, that database is never explored in a systematic way. So there lies a lot of opportunity for this challenge to see what we can get from the business, for some business insights to smooth the campaign process and to add to make some value for the MamaCrowd. The first step we dig into this database is to look at the user profiling. So in the Mamacron platform, each user is it has a diverse investment history, and it also has very diverse background of education, age, and investment experience. So we would like to see if we can categorize the user into different groups. So we assume that maybe some users, they invest much more than the other group, like this type of user. They are much more active in the investment more, and they are also much more active on their platform. So they are experienced users, they would like to invest more. And the other type of user, maybe they are just waiting there for the other type of user to invest first. They are more cautious, they invest less. So that's our assumption. You would like to build the user cluster, to build the user profiles to help to get some preference to enhance the user experience on the platform. And also, it is the first step to recommend the campaign to the user groups. So how do we accelerate this process? We need to find some user features first. So what is the good user features? We combine 3 sets of user features. The first set is the user background feature. That is applicable to both the old and new users. The second set of user feature is the user aggregated investment feature. So that's the user investment history in that website. The third set of the feature is the user action feature. It's like how many clicks the user on their website, how for example, download the document, view the campaign. So there are 3 sets of features. So why do we select those 3 sets of features? Because we would like to that be applicable to both the old and the new users. So it's a robust feature selection for both the old and the new users. Then we apply the Disney algorithm to reduce the dimension from a very high dimension data space to a low dimension space, which can be helpful to visualize the user and also help for the subsequent analysis. Then we apply the k-means clustering algorithm to cluster the user to small clusters. Then we find that, okay, there are several small clusters, but those small clusters can be combined to 2 big user clusters, where one of the user cluster, they tend to invest more money, like the total amount of the money, and they would like to invest much earlier than the other set of user. And we also find that for the campaign they invested, there's also a very big difference. For example, one set of users who invest more money, they didn't care a lot about the pre-value of the campaign, where the other set of users who would like to invest quite late, they would like to invest some campaign with a very high pre-value, and they care about the campaign result more than the other set of users. So actually it shows different user profiles I think it can be a useful step. And then we switch our focus onto the campaign recommendations. You can see that this figure is a demo campaign on the website. There are some descriptors of the campaign, like the minimum goal, the maximum goal, and those are some ongoing features of the campaign, like how many investors, what is the amount of investments, and how many days left. What we'd like to do is because there's a vast ocean of investment, we like to connect the dot between the correct campaign and the right user, so the user can follow the campaign, really resonate their investment philosophy. So the way we do this is also to first feature engineering some campaign features. Those campaign features include the feature I just showed, the features like the campaign descriptors and the campaign ongoing features. Then we use Disney to reduce the dimension of those high dimension space and apply the random forest to classify those campaigns to the 2 big user clusters. So what is the result? We found that we achieve accuracy. Actually, this is F-score with more than 60%. And we also find that the minimum quota value is a vital factor to classify the campaign to the user clusters. So the minimum quota value is a jargon, is a term in that website. So this is a minimum value the user need to invest for a campaign. And actually, this finding can lay a solid foundation for the subsequent analysis for the campaign recommendation. Finally, the MarvelCrown repository of campaign is not a static repository. It is ongoing. So we'd like to make more people realize their dream and connect the right users to more diverse campaign. So what we can do for this stage? MarvelCrown, actually, it has more than 700 company URLs in their database. And behind each of the URL, actually, there can be a very interesting, abundant, very valuable data. But that website doesn't have that automatic way to collect all the company information, to integrate the company information and select those in which company is more easier to go through the campaign. So we need some way to select the companies and select the most interesting one to go through our campaign. So what we did is to first use web scraping technology. This is the traditional one, but we combine that with a large language model. Everyone knows the ChatGPT or GPT-4. And we use that to summarize a description of the company. And also, we use some classifier to classify those companies to different industry groups. So the final result is a very detailed company profile and the industry group of different company. So this total process is automatic without human intervention, and we think this can greatly accelerate the business model. Thank you very much for your attention. I'm Ray, and this is Oma and Evan. We are working together for 8 weeks. I'm looking forward to your question later near the pool. Thank you very much.
Thank you, Rui. Thank you so much. I would like to spend a few minutes commenting a bit about the team and the challenge. First of all, I would like to emphasize, you see, we at PySchool, we are able to really select very good candidates. In this case, or also with different background. Rui is doing a PhD in the UK on generative AI applied in the music sector. Omar, he's a mathematician now turned into machine learning, and Ivan is a physicist now turned in HPC, high performance computing. They were really working on different branches of the challenge, but then collaborating together. And okay, this comment about, you see, people we are able to select is general to all the other challenge. Then I will comment also the other later. I would like to add a couple of points about this challenge in the last 8 weeks. So you see, from the sponsor, we had the opportunity to explore their data set, huge one, with some constraint, because you see, when you're dealing with a data set, there are also privacy factors to consider, and it's not as easy as you might think. So we were trying to understand business inside, considering also that some part of the dataset was not available to us for privacy reasons, and we were able to manage all this together. And I would also like to highlight that the data science sector is changing so fast. Also the techniques, so in this challenge, we were able to apply also standard and consolidated techniques like Rui mentioned, feature selection, clustering, but then, and basically it's my first time, you see, also mingle them with more recent one, like using a large language model like GPT-4, ChatGPT, coupled together with standard techniques to, you see, understand how the statistics and business insight from the data. So you see it's changing. I will see in the future will be more about the interaction of standard techniques with large language model, but we will see. So thank you again, and I will leave the floor to the next one. So, large language model, Akash, the floor is yours.
Thank you, Cristiano. Thanks. Hello, everyone. I'm Akash, and my teammate Ishan, who's unable to join us here today, and I have worked on large language models for K-12 education, sponsored by V Corp. So to give you a bit of a context, online learning has exploded in the recent years, and thanks to the pandemic, there has been a lot of adoption in the technology, especially in the education sector. And when we come to the effectiveness of online learning, we are able to see that there's a sharp dip when you kind of compare it with the manual teacher-student interaction. And according to a recent survey, you can see that 56% of the students do not find online learning very effective. And there are a couple of reasons for that. So the first one is the teacher is really not able to assess a student's progress, and the reason is because there's only so much a teacher can do through a screen, and it's also really difficult to have the student engaged because, again, in a small screen, there is a teacher has limited access to what one can do to, keep the student engaged. And of course, this is especially relevant when you talk about primary school children. Well, what's needed? There are three major points. The first one is, obviously, we need to have the concepts explained efficiently. We need to guide students and provide them with encouragement. What that means is, especially for small children, they need a little bit of motivation, a little bit of, yeah, you're doing good, things like that, to keep them on track, to keep them really engaged, and to guide them towards the goal. And the third one is to assess them and give useful feedback. So what that really means is the students need some kind of feedback from time to time, because that is what helps them stay on track. And without that, they could really be exploring a lot of things and not really learning anything. What we propose, one second. Yeah, the proposal is a chat-based generative AI model. So with the recent explosion of LLMs, you are able to, you see that it is able to, first of all, hold a natural conversational flow, and it's also effective in explaining the concepts efficiently and accurately. But it doesn't come with a few caveats, and some of them being the answers provided by the LLMs. For example, ChatGPT, you might be able to see that it produces the direct answer. If you give a small question, it straight away gives you the answer. That's not really useful to the student. The second one is it fails to guide students on how to approach the problem. Obviously, when you ask it in a specific way, it is able to do that. But a student will not have the patience and things to actually structure the prompt properly to get them to guide the student on solving the problem. And the third one is there is really a limited accessibility on what you can do with other services. For example, it requires a subscription, there is no speech input, there's no voice feedback, and there's only a text input and output. So this doesn't really work. Let's see a demo of what ChatGPT does when I kind of give it a very basic division problem, which is like 20 by 4, and it straight away throws you the answer 5. So with this example, you can see that that particular response is not very useful for the students in understanding what is really happening, how to do the division, how to approach the problem, and several other things. And I'm going to show you a demo of what we have achieved. And this is RUI, where it's called Genie. And here I ask the same question. And you might be able to see that it kind of starts with the problem. It tries to see what this question is all about. It explains about division. And then it creates an analogy that there are 20 candies and it needs to be distributed among 4 friends. So what would each person get? So it's kind of imploring the student to answer it. And I'm providing a speech input, asking if it is 5. And when you give that, it understands that this 5 is the correct answer and kind of congratulates you. And another important thing it does is it reiterates the question. It helps you, get the concept, and also starts with a different question. Yeah. And how we were able to achieve that, we were following 3 guidelines. So for the first one is it adapts to the Socratic style of learning, which is basically a philosophy that says that when asked the question, you need to guide the students towards the actual answer without actually providing them with the solution right away. And the second one is it's able to assess the student's ability to give personalized instruction. What that really means is when a student comes with a question, it first kind of understands where the student stands, and then based on that, it's able to continue from there. So a general LLM model would not be able to do that, because any question you ask, it's straight away the answer. And this one would actually place the students on particular tier and get them to really understand the concept. And the third one is we have incorporated a couple of accessibility features like voice-based input and output for better interaction, because primary school children cannot really keep typing their questions and chat with the model. Yeah. We really hope that this project gets to the hands of lots of children, and it's really beneficial. Myself, Akash, I'm a master's student at Stony Brook University, and my teammate is a machine learning engineer. Thank you.
Thank you so much, Akash. I will spend a couple of minutes. Want to add some details. First of all, big shout out to the team. They were based, Akash is based in New York City, Stony Brook, but close to New York City. Ishan instead is in California. So we were meeting where, let's say here was late afternoon, and for them early morning, and then basically they were working when I was sleeping. So it's we were able anyway to manage this challenge. I want to spend a couple of I want to tell you a couple of details. Basically, as soon as ChatGPT, but before ChatGPT, GPT-3 was released, after that, the world of AI slightly, maybe not slightly, but highly changed. So it was a disruption. And many interesting things are happening. I like to call it is a new science of LLM, a new era of AI, basically because not only we are dealing with new models, but we need to understand the behavior of this model. It seems strange, but they have some kind of behavior. You need to understand how to interact with them. And so basically this challenge was about, you see, constrain the model not to give the right answer immediately, but to, you see, provide the way through, you see, understand the problem and find a solution. And this was very cool. I also would like to emphasize that basically we were connecting method, the Socratic method that was invented and developed by Socrates and then Plato, implemented in this new large language model. So it's a connection, you see, almost many years between them, but it's cool, in my opinion. And that's all my comment. Congratulations again to Akash and Ishan. And now I would like to invite to the floor Lorenzo and Janine. They are from We Corp, so they are the sponsor of this challenge, and they will add some details more, and maybe, who knows, tell us next steps.
Thank you. Okay. Thank you, Cristiano. Let's see. Nope, that's the wrong. There we go. Okay. So we're our corporation, so our company is a very young startup as well, and we're focused on providing solutions that overall contribute to the well-being of society. So it's a big ask, but as former Minister of Education here in Italy, Lorenzo, education has been something that has been close to our hearts. So we're looking into, we had the opportunity of working with amazing engineers here from Pi School, and it's been a really great experience. So our business pain was, what do we do to help children? And I think a lot of us have been experiencing this also through the pandemic, how to actually tutor them without necessarily having a one-on-one interaction all the time with teachers, in particular students with special needs. So this is what our ask was, and it was a big one. So can we have an AI tutor that supports teachers, children, and parents, and focuses on the individual need of the student, that can also provide a responsible and child-safe environment for them to interact with. And that doesn't provide them the answer, but actually helps them get through the answer. So that is the most important thing that we were looking at. So as you saw earlier from Akash's presentation, we were presented with Genie. So we had the idea of Genie that can guide the person, the student. We were focusing mostly on elementary school age, but this can also go beyond. That helps them get to the point of their question, but also keeps them engaged. So if the student goes there and asks them the question of their homework, they're not necessarily going to get that response. They're going to get a guidance tutor that helps them get there. So why do we need it? Why do we need something like Genie? We need something like Genie because not all families have the time and the skill set to support students throughout this process when they go home and need to deepen their knowledge on what they learned in school. Teachers can use Genie and need Genie to help students focus on their individual learning needs and keep them at their level. So be able to support them at their level. Students themselves can further and deepen in a fun way, in a fun and interactive way, what they've learned at school. And in schools, it's also useful because nobody gets left behind and you're actually using the full potential of all students and tapping into the full potential of all students. What are the next steps? Just briefly, we're at the testing phase at this stage. We're starting to roll it out to a few students just to get a bit more an idea of the benchmarking questions that we have asked it and see to what extent there's to this stage, at this stage, there's no problem with the accuracy, but we just need to extend also the scope of the types of questions we're asking it. We also want to further it into Italian language and provide this as an option for Italian students, Italian-speaking students. We want to secure, of course, its sustainability, which is something that at this stage is a question mark, and a team that helps us debug and further develop different interfaces of Genie as we go along. We think it has a great potential in terms of direct user engagement for schools, for students, and after-school programs. So that's my part. I don't know if you still want to...
I'm just going to add something. I'm not sure this is working. Sure. It is working. It is working.
Okay.
It's working. So I really want to thank you guys. You've done a great job, Akash and Ishan. It was really beautiful. I had the honor and privilege and the personal sacrifice of leading the education ministry here in this country a few years back. And when I was a national minister, I remember families in this country were always upset with the amount of work, homework that students get at school, the fact that parents cannot follow them, cannot be there all the time. I think in a sense, modern school has become very time intensive for everyone. And what we found out is that if you're coming from a family with money and knowledge, you do well. If you're coming from a family without money, without knowledge, and often without time, you're not going to do well. So for us, Genie was a way of rebalancing social inequalities here. You know, like you need to have access to someone that can guide you even when you're not a millionaire, when you're not rich, when mom and dad are at work, or maybe when mom and dad don't have the expertise to be able to guide you on math, chemistry, geography, and so on and so forth, or in a foreign language. So for us, this is really an opportunity to match business with a social cause, with what we call well-being. And if you think about it, it's also a very powerful way to make sure that AI is perceived as really enhancing our ability to acquire knowledge rather than taking it away, which was probably one of the first reactions to ChatGPT. You know, when it came out, probably many people thought, okay, we're never going to learn anything because students will cheat. They're never going to study anything because they can find answers right away. Here we're demonstrating that actually AI can be used to enhance the ability to acquire information, to be able to be guided, to be able to be tutored and learn better rather than avoiding learning in the first place. So I think in a sense it responds to a challenge that schools have all over the world, the families have all over the world, and also it supports the good cause of AI, projecting an idea that AI can really emphasize good learning and not take away the pleasure of acquiring information because you know there's a computer who's going to do it for you. Thank you.
Thank you. Thank you so much. Super interesting also from my side working on this project and working with you. Now I want to leave the floor to the last one. Here it is. Okay, sorry. It's your turn. Pritesh.
Thank you, Cristiano. Namaste, ciao, and hello, everyone. I am Pritesh. My teammate Rohan and I built this project, Natural Language Access to Photo Archive. To give you a bit of context, Mapix, our sponsor, they manage digital assets like images, videos, audios, and text. And their end users are people from photo agencies, historical archive, fashion archives, and publishing sectors, and many more. And it is very common to have a website like this in this sector, where you'll find a lot of checkboxes. Sometimes these checkboxes can be in hundreds. And it's very difficult to find a particular checkbox related to your query. For example, if I wanted to search an image about Colosseum, and I wanted it to be a vertical image. See, I have to navigate through the format, select to the vertical, and get the desired results. What if I had to select multiple checkboxes? It will take a lot of time. And we can solve this. Just imagine the search using natural language, where you can just type in the query, I'm looking for a vertical image of Colosseum, and get the desired results. Here, you can see vertical is already selected. Why search in natural language? It is intuitive compared to checking the checkboxes. It is faster. Now you don't have to navigate through the checkboxes and search the menu. It is scalable, and I'll show how it is scalable. Mapix, they have different clients, such as YNT. It consists of a lot of historical images, and it has like more than 15,000 images. AGF caters to international and national politic and entertainment images, whereas Blablut is about fashion and lifestyle, and many more. All this website have something called attributes. What do I mean by attributes? You saw those checkboxes in the website, right? So those media type, position, moment virtual fields, these are represented in the checkboxes. You can see they differ from the archive. In first archive, we have media type, position, moment virtual field, whereas in second, we don't have position. We have something called moment position. And we have a new attribute called image cut. In third archive, we have moment position, but we have a new attribute called moment color. And to access these data, we use something called MQL, Moment Query Language. It is similar to SQL, but very simple. So given a query, I'm looking for a vertical image of Colosseum. Our MQL will look something like this, where media type 1 represents image, position 1 represents the orientation of the image, and Colosseum is the keyword. And now our problem statement is very clear. Given a natural language, we have to generate an MQL. To solve this problem, we tried different approaches, such as extracting keywords, trying sequence-to-sequence models, and LLMs. And given the limited data we had, and the schema of the archive, we came to the conclusion that LLM tends to perform really good compared to any other models available. To create an MQL, we have something called template about the archive, which contains all the attributes that I showed. Attributes are the checkboxes, again. We combine these rules with the natural language query. We add them together. We pass into the LLMs and generate MQL. How we are going to scale for different archives? So to do that, we have created standard template. We add and remove the attributes. Again, attributes are the checkboxes and menu boxes. To create a standard template, we have natural language query. We combine them together. We pass to large language model and create an MQL. These are some results. Here I wanted to search for images representing Vatican. And at the bottom, you can see media type is 1 and Momonet category is VAT. This Momonet category represents Vatican. And this is one of the checkboxes which is there in the website. In second image, I wanted to search for Giorgia Meloni. Here media type is 1 because I wanted to search our image and the corresponding keyword. In this case, I wanted image of statue by some artist, and the media type is 1, and this virtual field, it corresponds to that artist. And it is also one of the checkboxes in the website. In the last one, I wanted an image about where I don't have to pay royalties, basically license-free images. And you can see this license 2 represents license-free images. At the end, I would like to thank our sponsor. They were really helpful, giving us feedbacks so that we can make this system really robust. I'm Pritesh. I'm a research fellow at Indian Institute of Technology, Kharagpur. I'm also a deep learning researcher. I work on 3D computer vision problems and recently NLP. My teammate is Rohan. He's a fellow at Fatima, and he's NLP researcher. Thank you.
So thank you again. As usual, I want to give a couple of comments. First of all, before I told you about the other fellow were coming from the United States, New York and California. Pritesh and Rohan instead were based in India. So again, we were able to communicate very well with them. And in addition, I must tell you that they were very, very committed to the challenge. They never missed a call, a coaching call, a tech talk, never miss a call with a stakeholder. You see, in 8 weeks could happen. Never. In your case, also Rohan. And so you were very, very committed. And during the challenge, we also changed several times. You see, techniques, tools, libraries. So really, congratulations. I want to add, you see, this session, I think it's the first time also for PySchool and as coaches to deal with with large language models. So think again about ChatGPT, GPT-4, but used in a more professional way. So it was the first time. We were also, as a coaches, junior in large language model, and we understood many, many things. We learned a lot, not only the fellow, I think, but also us as coaches. And we learned that the power of large language model is really huge, but at the same time, it's very easy to build, I don't know, fancy tools. But then, when you need to convert them, transform them into real, you see, product or real challenges, projects, it's a matter of really going through many, many difficulties, but also, you see, methodologies. So I must confess that I also learned a lot from it. LLMs and prompt engineering as well. This is a completely new technique. It was not possible 1 year ago. And also the fellow need to learn you see, a new paradigm program. Again, these were my comments on this challenge. And I think now that, okay, here we are. From MomaPix, thank you so much.
Thank you. Good afternoon, everyone. I'm Ornella Caradonna, the product manager for MomaPix. It is the digital asset management software created by MomaSoft. It's a pleasure to be here today, so I want to thank you, the PySchool team, the PySchool, for organizing this event. Right. Just a few words about our company. MomaSoft was founded here in Rome in 2006, and it's been fully dedicated to the development of digital asset management solutions for visual contents. Since the beginning, MomaPix has been offered as a software as a service. Now we have dozens of international clients among photo agencies and companies whose demands and expectations are high. So of course we need to always offer cutting-edge technology. Over the years, artificial intelligence has been revolutionizing many industries, and we at MomaSoft recognize its potential early on. This is where, our collaboration with PySchool comes into play. Because we'd like to integrate the cutting-edge AI technology into our software MomaPix by collaborating with the talented team at the PySchool. The key highlight of our collaboration is introducing the natural language search in our software. This could be really a game changer, because it can enable users to find assets effortlessly by simply typing in plain language. This can bring many benefits to our clients, such as faster responses to their clients who make searches on their installation, their website, and better collaboration across languages, and in general a competitive edge in the global market. So I can say that we talked about this project to some of our international clients, and there's great excitement around it. So thanks again to the PySchool team for this great collaboration. And we are proud of, I can say we are proud of bringing together this transformation in the digital asset management landscape. Thank you.
Thank you. Thank you, Ornella. Thank you, Saverio, who's somewhere in the room. For sponsoring this project. We enjoyed it, and I'm glad that to you it means excellent business. Now I'm going to give you a few highlights, news about PySchool, so what's going on besides all these projects. One highlight has been, well, a couple of weeks ago we started a new collaboration with the European Space Agency, with their branch located in Frascati, not far from here. The branch doing Earth observation, so the satellites looking down, not the satellites looking up. PySchool, we're essentially doing a version of PySchool of AI for the European Space Agency, meaning we'll run their internship, visiting researcher, visiting professor, and joint research sprint schemes, which are the sprints, the schemes by which they interface with the world of research. Okay, so we're going to run essentially very much the same mechanics as we already do for PySchool of AI, but applied to Earth observation, especially at the interface with emerging technologies such as obviously AI, but also quantum computing, Internet of Things, and others. So this has started with a kickoff a couple of weeks ago, as I said, in Frascati. And we'll move on with we believe we're planning the first competitive call for applicants. So, well, researchers, professors, people who want to apply to this are welcome to well, visit the website that we're currently building, and we think that this will happen by January 2024, when we've worked out all the like contractual details, the financing, the funding that all of these you know, people will receive when they work on these schemes, and so forth. In other news, I'd like to announce that PySchool is the recipient, together with Translated, of a pretty big grant from the European Commission for research. It's on the Horizon Europe program. Project is called MeTween. It's about speech technology. As I say, we want to solve speech, so it's a pretty ambitious research program here. It's especially applying speech technology to video conferencing, because we think that there's a lot of progress to be made here. Agents to support video call management, your personal avatar to represent you in calls. This is a 4-year research project. So mind you, this is going to, you know, finish in 2027, and by then, which, you know, stuff that might sound like science fiction here, we believe actually will no longer be science fiction, and it will actually look very credible, if not obsolete, by 2027. So it's a €7 million project over 4 years, as I said. We work, for those of you in the know, we work on foundation models for speech. So foundation models are things like large language models. They're called foundation models because essentially they're trained on huge quantities of unlabeled data. So typically it's easy to get by unlabeled text in the sense that it's just text with no extra information attached. Audio or speech, when it's found on the internet, imagine the audio track of YouTube. Well, this is unlabeled speech. And when you pair it together, imagine you pair together an audio track with the video track of a speaker. So imagine me in a video conference setting, you see my lips moving, you see my gaze, you see facial expression. Well, all of that is in sync, obviously, with the audio track. And when you transcribe it, you've got 3 modalities for speech. You've got text, audio, and video. And this is what we want to build single big foundation models for, so that we can then apply these models to downstream tasks, such as speech recognition, speech synthesis, speech enhancement, speech-to-text translation, speech-to-speech translation, and so on and so forth. So many different downstream tasks. This is the point of foundation models. Big model serves very many downstream tasks. Project is pretty nice because it will have high impact. We've designed it so that we can open source all of the productions of the project, starting with data, continuing with trained models, and finishing with the benchmarks. So evaluation data and benchmark libraries, think glue or super glue if you work in NLP. We've already secured 600,000 hours of A100 compute, and we're hoping to get more during the project. We are hiring for this project, so if this is of interest to you, and you're either finishing a PhD or you're beyond, then check out currently just Translated's website. We'll put it onto PySchool's website as well, where there is the job ad already and you can start applying. And then session 14 of PySchool of AI is in preparation. We're hoping to start session 14 mid-November, so in a couple of weeks from now. Follow the link if you're interested and if you have a business problem that you'd like us to work on. And finally, I would like to announce the launch of a course that we're running with Lewis Business School. So we have a Lapo here, he's raising his hand, from Lewis Business School. This course will start 21st of October. It's meant for executives, managers, business people in general, so no technical background expected. It's all in Italian. It will last for 2 months. And as you can imagine, it's about managing AI. So it's the tools that managers need to possess in order to do well in this changing world where a lot of things happen using AI. So we're going to work on these topics here: data governance, what you can, what you can't do, legal aspects, how to produce or collect data, business models for AI, so those business models which are a bit specific, for instance, the issue of bootstrapping, data collection. When you have a startup, you want to build an AI solution, usually you have the very important problem of cold start, so you don't have any data, but you need to have an AI solution, so what do you do? AI project leadership, AI ecosystems, and so forth. Starting October 21st, speak to Lapo if you're interested, or register online. And, well, this concludes, I think this is the last slide of my presentation, actually. This concludes our evening here, the pitch presentation. So at this point, we are going to say goodbye to all of the people who are here, this camera, I think, who are following us on the live stream. So thank you for following, and we hope to see you again for pitch session number 14. Bye.